Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on February 26, 2026, just yesterday. It presents a fascinating reality check for latent visual reasoning, showing that current models largely ignore their own hidden thought tokens, while a new text-based method called CapImagine outperforms them by 4% on the HRBench 8K benchmark. The paper is titled, Imagination Helps Visual Reasoning, but Not Yet in Latent Space. And as we'll see later, these findings challenge the core assumption that complex internal states equate to actual reasoning. And for those interested in the implementation, the authors have shared their code on GitHub. To set the stage, Figure 1 compares three competing paradigms for visual reasoning. The top section shows the traditional tool-based approach, where the model calls external functions to manipulate images. Below that, Panel B illustrates latent imagination, where the model attempts to reason using hidden internal states shown as blue tokens. Finally, the bottom panel introduces the text-based alternative, which replaces those opaque hidden states with explicit descriptive text, making the reasoning process transparent and, as we'll see, more effective. So Figure 2 details the investigative framework and the evidence it uncovered. On the left, Panel B uses heat maps to track token similarity. The deep red blocks show that latent tokens become nearly identical across different images, effectively collapsing into a uniform state. In contrast, the text reasoning matrix displays a clean diagonal, meaning text tokens remain distinct. Moving to the right, Panel C tests causal impact. The top charts reveal that replacing hidden tokens with random noise changes the accuracy by less than 1%. Finally, the probing analysis at the bottom confirms that relying solely on these tokens drops performance below a blind guess. So, having identified that latent tokens are ineffective, Figure 3 introduces the author's solution, CapImagine. The top section displays the original data, where reasoning steps are interleaved with evolving images. The middle section contrasts the approaches. While latent methods on the left try to compress visual changes into opaque blue tokens, the new method on the right verbalizes them. For instance, it explicitly states, suppose a red rectangle had been marked inside a think image token. Finally, the bottom panel details the construction pipeline, where QN3VL4B generates captions and refines the reasoning chains to ensure natural flow. Alright, with the method defined, Table 1 delivers the verdict. It benchmarks CapImagine against proprietary giants, like GPT-4o, open source models, and prior latent reasoning attempts. If you look at the blue section for imagination methods, CapImagine consistently outperforms the latent baselines, LVR, and Monet across the board. For example, on the versus star benchmark, it achieves nearly 86% accuracy, beating Monet's 83% and significantly surpassing GPT-4o at the top, which scores roughly 68%. The final rows show that skipping the rewriting or filtering steps hurts performance, confirming that high-quality text data is key. Well, Table 3 provides the critical sanity check for this new method. Remember how, in the latent models, scrambling the hidden states barely changed the outcome? Here, the story is completely different. The row labeled CapImagine do Z shows what happens when we intervene on the text reasoning process. Under the versus star average column, the accuracy crashes from roughly 86% down to just 23%. This massive drop of over 60 points proves that CapImagine actually uses its generated thoughts to solve the problem, unlike the latent baselines. Figure 4 now visualizes the internal diversity that drives this performance. The three panels on the left display the inter-instance analysis, tracking hidden states across different inputs at the 2nd, 9th, and 16th steps. Unlike the latent models, which collapsed into uniformity, these blue heat maps show low similarity everywhere except the diagonal, meaning the model keeps each input's representation distinct. On the far right, the intra-instance matrix confirms that even within a single reasoning chain, the tokens remain diverse, proving that the text generation is actively adding new information at every step. Wrapping up, the main takeaway is that current latent reasoning is largely a mirage, as models essentially ignore their own hidden thought tokens. By contrast, forcing models to explicitly verbalize visual steps, as CapImagine does, creates a genuine causal link that significantly improves accuracy. Transparent reasoning simply works better than opaque complexity here. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.